talking about remainder theorem. So remainder theorem, what it means. So suppose in simple words, if you take any number, for example, I was telling if you take a number and if you divide the remainder, so what will you get? So what will you get? So the remainder is 2. So here this one is called remainder and this one is called quotient. This one is called divisor. Very good. And this one is called okay. Now, how is this to be written in an equation form? Equation form f of x equal to, suppose if I take this as f of x, f of x can be written as q of x. If I take that divisor and the quotient, if I take the divisor as q of x or divide this one as any one of the notation. Maybe if I take this one as g of x and this one as q of x, so I could write this as f of x equal to q of x into g of x plus this one is r of x in polynomial form. This is the number, it's a numerical calculation. In polynomial form, you can write in this notation. This is what we saw in the previous discussion. Okay, so what it is going to do in IoT? Actually, what is going to happen in IoT? Suppose if you have a smart home, suppose if you take a kitchen, so you have a smart fridge, you will have a washing machine, you will have certain things. So what this IoT says is you can interconnect all these devices. That is to your mobile. You can see what is the temperature of your freezer in the fridge using your smartphone, or in a smartwatch you can get some data. So what the problem here is, are you getting the same data? Are you getting the correct data? Okay, so suppose for example, there is a home. It's a smart home. So it is under surveillance of some cameras. So you are connected all the cameras, you are connected all the devices, whatever there is a home. Suppose if there is a malfunctioning, how will you understand it is not working properly? For example, am I getting the same data? See, what you say is, in Internet of Things, what you say, device and device talk with each other. Am I right? How will the talking take place? So it will send a message to the other one. Am I right? The message will be sent from the sender to the receiver. The communication happens. For example, the fridge will say, okay, now the temperature of this freezer is this one. It comes to your smartphone or smart mobile. Okay, whatever you say, or smartwatch. Okay, so you get the data. That is one point. The second point is, you are going to give some work to the devices. Let us assume there are 10-15 devices of same kind. It's going to do the same work. You are going to give a message that do this work. If the work is equally allotted to every machine, maybe let us consider an industry. So, work allocation, even in work allocation, there may be a problem that allocations may not be proper. So, the instruction given to the machines may not be proper, some errors may happen. So, what this remainder theorem is going to do is, suppose if there are two polynomials, let us assume there are two polynomials, you are dividing them and you get some answer. Okay, you get some answer. Let us assume you get a quotient, you get a remainder. Okay, you get a remainder. So, you know by division, this is the right remainder, this is the exact remainder. So what you say is, if the remainder of this calculation is correct, the data transfer is correct. That is how we connect. Okay, this kind of remainder concept is connected with the data transfer. So how we understand the data transfer is correct is, if the remainder what I get is similar to what should be got, the data transferred is the correct one. Okay, so that is how we connect. So simply saying, wherever we go into the concept of IoT, information sharing is happening. The information sharing can be of any type. Maybe giving a task to some machines. Suppose that giving a task to a machine is not correct, not perfect. It will do some other unwanted, unrequired, some kind of work. which is not the perfect. So there may be some dysfunctioning happening. Am I right? There may be some dysfunctioning. So in order to avoid that, and also for security purpose. So everywhere we go, you can have this kind of idea. So you can easily say that, sir, if you divide this polynomial with this polynomial, this is the quotient you should get, and this is the remainder you should get. If you know this already, and if you connect with the message transfer, so easily you can see whether you are getting this outcome connected with the data that is connected with the quotient and the remainder. So if the remainder and quotient are the correct ones, once after the process is completed, then you can say the data transfer is correct. Okay.